Okay, welcome to part 2. Graphing sines and cosines. Alright, so we've talked about the basic format of sine and cosine. We've got these letters that we can throw in there. Here's cosine. We know that A is the amplitude, B changes the period, right? P equals 2 pi over B. And then we've also talked about how this is the midline. It's the middle of the graph. Same with the cosine ones. And then we've dealt with the A and the B and drawn graphs with those. But there's two more things, well, technically three, but two this time. One of them is reflections. So if you look at this one, red's the original, blue is the new one, and what's changed is a little negative is out in front of here. It still has an amplitude, of 1. The difference is that it's reflected. Now, a reflection just means, if you look at this, here was my sine. I had beginning, middle, and end at the intercepts. Between the start and the middle was a maximum. Between the middle and the end was a minimum. When it comes to a reflection, that just means this maximum moves to the other side of the midline and becomes a minimum. This minimum over here flips to the other side of the midline and becomes the new maximum. So that negative out front means it's been reflected over the x-axis. So reflections mean max goes to min, and any minimums go to maximums. The intercepts do not change. So over here with an example of cosine, again, there's still an amplitude of 1. It's just anytime you have a negative inside here, that means it's been reflected. So looking at the original graph here, the red one's original. Cosine starts at a maximum, ends at a maximum, and has a minimum in between. And then there's the two x-axes. Sorry, intercepts. Oh, that was weird. Hit the wrong button. Anyways, so key points of a cosine. Now, when it comes to reflections, the maxes become mins. Whoa. Somebody's messing with everything. So this maximum over here became a minimum. And then this maximum, they have to end the same, so it now got flipped, and it's now a minimum. And of course, this minimum right here also gets flipped and becomes the maximum. The x-intercepts do not change. Sorry, the midline intercepts, because we're going to end up moving that midline up and down. So get used to it being the midline. Okay, so this is basically it for reflections. All that means is you have your regular 5 key points and drawings. You need to flip them over that midline. Let's try one. Okay, this right here says it's been reflected. Okay, still looking at it, we can say that our A is 1, not -1. The negative tells you it's reflected. The number right here without the negative is the actual amplitude. All right, we've got a B of 2, which means our period is 2 pi over 2, which is pi. And then just to cover my bases while I'm here, we're going to take the period and divide it by 4 to tell us what to count by. So, as always, you graph. You count out 1, 2, 3, 4 lines. That's where your period goes. And then you count 1 pi fourth, 2 pi fourths, which reduces, 3 pi fourths, and then your period. Now our amplitude is 1. And again, I like to draw when it's just got an amplitude of 1 so that I can see things better. I'm actually going to put that as the 1 up there. All right, cosine says we have 5 basic points. There is an intercept, it starts at a maximum, ends at a maximum, and has a minimum halfway between. And then we've got our 2x intercepts. Now that's a basic cosine. In order to reflect it, again, the intercepts don't change. I should say where it crosses the midline doesn't change. But this maximum is now going to switch to the other side, and it becomes a minimum. Same thing with this guy. And then this minimum right here is going to change sides and becomes an actual maximum. And then just like the other ones, you connect them with a smooth curve. And that is your new reflected function. So g of x equals negative cosine of 2x. All it is the irregular one flipped upside down. Okay, now let's talk about the midline changing. So right here in this first one, this blue one, its midline is the y-axis, x-axis, which is at y equals 0. Okay, so y equals cosine of x looks like this. Max, max, min, intercept, intercept. But when we've changed this one, it's midline, and you can see this because the max is here, the minimum's there. So halfway between is the new midline, right? So it's at y equals negative 2. And what's happened is each point has gone down because it's negative 2 spaces. So look, this maximum right here, 1, 2, and that's how we need to put it there. This minimum down 1, 2, and that's how it went there. Same with this guy. And then the intercepts as well, except for now instead of intercepts, it's the points where they cross the midline. So they were intercepts, but once we start changing that midline, it changes to a different function. This one over here is sine. Oh, the equation for this one. The new one would be cosine of x minus 2. Remember that plus or minus d was the midline. Okay, the sine one over here, y equals sine of x. Sine's key pieces are 3 intercepts, beginning, middle, and end, and then a maximum between the first 2 and a minimum between the second 2. This midline right here for these guys is at y equals 0. That's the first one. Now the equation of this new one right here is y equals the sine of x plus 2. What that means is my midline is now up here at y equals 2. So if you compare those two, you'll notice that this point right here is just lined up with this guy because it's 2 up. Same with this maximum, it went up 2, intercept up 2, and up 2. So when you're given a graph that's got that change to the midline, that's all it means is take your original points and move it either up how many ever and down how many ever. Let's look at one. Okay, this is the sine of x plus 3. Now, you're still going to go through and decide on your amplitude, your b, which is going to help you find your period. So count out 4 lines, 1, 2, 3, 4. That's going to be 2 pi. Okay, and then to do p over 4, that would be 2 pi over 4 or pi halves. Okay, so 1 pi halves, 2 pi halves, and 3 pi halves. All right, and then the amplitude was 1. Again, I'm going to go here for 1. Oh, no, we can do there. Sorry, that was my bad. So this is going to be 1, 2, 3, 4. And down here is -1, -2, and -3. That should be enough. Okay, now I'm pretending for a minute that there's no D right here. I'm going to ignore that for a minute. I'm just going to graph this basic graph of sine. Oh, I'll even do it in a dashed pen. I'm going to graph these pieces and draw the regular sine. Then I'll come back and deal with that whole midline thing. So sine starts at an intercept, ends at an intercept, has an intercept in the middle. Then the basic ones are, there we go. And then that is your regular basic sine curve. Now that's not with the midline put in there. I was going to do it in dots. Whatever. Sorry, forgive me for a moment. Need to color code it. So D equals 3. Okay, now let's talk about what that means. So right now my midline's at 0. And now it's supposed to be up here at 3. So at 3, that's your actual midline now. So to graph it with that midline, the easiest way I think to do it is to go, okay, it was here was my starting point. This amplitude this D means that it's changed up 1, 2, 3, and that's where that new point goes. Okay, this one, count up 1, 2, 3. There's your next point. Up 1, 2, 3. 1, 2, 3. 1, 2, 3. So this is the way I usually graph it. Now, if you want, you can just look at the midline as similar to the x-axis. It's just moved. And then beginning, middle, and end are your intercepts. Going up 1, going down 1, or the amplitude will give you the other points. But I tend to like doing it in different stages because eventually you're going to have multiple stages. So it helps to see it piece by piece. So this purple one would be your final answer.